Hello and welcome to today's WorkSafe Month webinar, Using Wearable Technology to Reduce Injury Risk. I'm Stephanie Borowski from WorkSafe Tasmania and I will be your moderator. Before we start, please take a moment to read the following slide about information received today. I'll now go over housekeeping. Here is a screenshot of the attendee control panel. You should see something that looks like this on the right hand of your screen. You're likely listening in using your computer speaker system by default. If you would, however, prefer to listen over the phone, just select telephone in the audio pane and the dial-in information will be displayed. Webcams and audience microphones will not be used in today's webinar. Questions will be taken throughout the presentation. Please use your control panel to type and submit your questions. Finally, today's webinar is being recorded. I would now like to introduce your presenter, Scott Coleman, Chief Executive Officer and Injury Prevention Specialist from Preventure. Scott has become an industry leader in workplace injury prevention through his innovative and comprehensive approach to using wearable technology. This approach evolved from the combination of over 20 years' experience working with elite athletes as a coach, physiotherapist and biomechanist, with the skills developed working in private practice treating injured workers. Over the past 5 years, Scott has been partnering with large organisations, workers' compensation insurance brokers and safety consultants to reduce the costs associated with workplace injury using wearable technology and data analytics. Welcome, Scott.
Great, thanks, Stephanie, and thanks everyone for taking time out of your busy day to spend an hour with me and hopefully learn a few things. And if you have any questions throughout, please feel free to type them in, and Stephanie will actually read them out. So rather than getting to the end and having a barrage of questions, if a slide comes up that you'd like to know more about, then pop the question in the box and we'll address it at the time. So to start off with a bit of background, so I was a sports physio for 15 years, and at the elite level of sports physio, but even not just from an injury prevention and a physio and a sports medicine perspective, but from a performance perspective, every individual is different. We spend a lot of time with the repetitive loading sports. So rowing is what we're going to talk about for the next slide, but athletics, swimming, a lot of those repetitive loading sports they are similar to the workplace in respect to there's no impact, there's no contact. A lot of injuries and a lot of the stress and the overload comes from a mismatch between the amount of capacity of the individual, whether it be an athlete or a worker, and the demands of what they're trying to do, whether it be a sport and the training load or whether it be a workload in a particular work environment. So early on, I realized that data can be really powerful to identify the demands of the task, whether it be a sports task or a work task, and the capacity of the individual to withstand those demands. So what we've got here, this is a chart of the best 8 rowers basically this is a 2008 Olympic cycle. And you can see there, even though they were all finely tuned athletes, very highly trained and specific in the sport that they did, what you're looking at there is their power curve. So every single one of them, just due to their genetics, due to their biomechanics, their leg length, their limb length, they all applied force, or they all did the task, which was pulling on the oar, slightly different. And we could use this information to work out exactly where the athlete should be in the boat to maximize their efficiency, but minimize their injury risk. So this is where, and the purpose of this slide was to show you, even at the absolute elite level, there are variances that can be measured, and that information can be used to reduce load or to reduce injury risk. So the current problems with workplace injury prevention programs, I transitioned across from sports injury prevention to workplace injury prevention because my mother sustained an injury working as a nurse, and her injury prevention program was a safe lifting manual that she had gone through when she started 6, 7, 8 years prior. And here I was using quite basic technology to measure, as I said before, to measure the demands of tasks to measure the capacity of the individual to do the task and to flag injury risk that way. And there was none of that happening in the workplace. And she ended up with 7 levels of her spine fused because of it, because of an ineffective injury prevention program, which at the time, this is only 6, 7, 8 years ago, at the time that was pretty common, and it is unfortunately still pretty common today. So current problems I found coming from the most effective injury prevention sphere, which is the sports medicine environment, to the workplace, I found education training methods were ineffective at changing behaviour of the workers. A lot of the programs suffered from limited time and resources. A lot of safety teams, as you all know, are very short of time. And when you've got a workforce scattered over a big geographical area, or just a large workforce with a lot of people, then your time and your resources are limited. And approaches are not specific to the individual injury risk. There's a lot of a blanket approach. I found if a worker was over a certain age, straight away their injury risk was classified, regardless of how resilient they were and regardless of how strong they were. And likewise, younger workers, 18, 19, 20, were straight away put in a lower risk category, even though their biomechanics or their what we call training age, their efficiency of the tasks that they were doing were not measured. So they could have been a higher injury risk compared to the older workers who've been doing the task for a long period. And assessments were observation and opinion based. There was no data collected. It was all very much focused on the expert opinions. And there are some great experts out there, but we know inter-rater reliability, intra-rater reliability for that matter, of your rulers and your Rebas and a lot of those assessment tools aren't the best. So there was a need to collect data and to make it a bit more objective, which is what happens in sports medicine. So the most effective injury prevention programs use sports-based programs, which is the TRIP model. And TRIP is pretty straightforward. It stands for Translating Research into Injury Prevention Practice. So pretty straightforward, but it was really well done in sports, and it doesn't seem to be a lot of the safety-based research and ergonomics-based research. There's a bigger gap between the research papers and what the universities are finding and the application of those findings to the workplace. You need to measure movement quality and quantity. So a lot of the other tools that are around at the time, well, when I first started transitioning the sports wearables and sports methods across to the workplace, a lot of the tools that were available measured movement quantity. So they measured how far people would reach and how far people would bend and the trunk movements. But we know, like, if everyone right now stood up and very slowly bent forward and touched their toes, it's a good stretch for their back. It's a good stretch for their muscles in their pelvis and their legs. But if they did that as fast as they can, if you all stood up, touch your toes as fast as you could, that's a really big injury risk to your back. Now, the range of the movement's the same, but it's the control that matters. And that's what sports injury prevention programs and research has shown over the years. Control of movement is crucial at identifying injury risk. Exactly the same as doing overhead tasks. You could do an overhead task with your hand above head height, which we know is considered hazardous. You do it smooth and controlled for a short period. The range is the same as if you do it in a fast, uncontrolled way. It's the control of the movement that really increases the injury risk. So that's where a lot of the workplace injury prevention programs differed from sports programs. It's that movement quality that was lacking. Establishing specific baselines using load. So identifying the needs of your work group and establishing baselines with them, not taking baselines from externally. Most professional sports teams, they've got their own internal load monitoring program. They've got their own internal benchmarks that they want their athletes to abide by. They don't use a general sports-based or sports-wide threshold for hamstring injury risk or for knee or shoulders for swimmers. They look at their particular thresholds within their training group, and that should be the same in the workplace. You should get benchmarks. You could collect data from all your workers and collect averages, and then use the averages as benchmarks. So the guys above, or the guys and girls above the average, should be trying to get below average, which then brings the benchmark down, which has this perpetual improvement cycle. So I mentioned load a couple of times. So I put a definition there. Load is the process of quantifying the amount of physical training. So in the workplace, it's about quantifying the amount of physical work that an athlete or a worker undertakes using variables relevant to their sport. And that's the same in the workplace, variables relevant to their workplace, which we'll go into in the next couple of slides. So preventative measures, you've got in the workplace and on the sports field, you've got primary prevention, which everyone seems to be really good at in the safety sphere, which is task assessments and screening. Pre-employment screening is really good. Return to work screening is really good when people are returning from an injury. Task assessments are good. Like I said before, they're very subjective. So there is a need for more data with task assessments. Secondary prevention is where the health and safety industry tends to be a bit lacking, which is early detection of onset of signs and symptoms, which we'll get to in a minute. Then tertiary prevention, again, really good at, because return to work and the rehab side of the workplace health and safety industry is really good because of the workers' comp system. However, it's this secondary prevention that is where there's gaps, but it's also an opportunity. It's where there's the most opportunity to identify and reduce injury risks. So this secondary prevention, this is again the sports medicine model where you've got an injury onset. This is musculoskeletal injuries. So where your repetitive overload or your strains and sprains and the ones that are causing us all that much trouble in the workplace, they have these phases. There's the biological onset, and at that point, you can't detect it. The worker can't even detect it. There's microscopic changes to muscles. Muscles might start to deteriorate and get microscopic breakdown. And that's the next phase, the detectable signs. That's where the muscles start to feel tight. They start to ache, where unfortunately a lot of workers just push through. And it's those first two phases where the most change can occur using wearable technology, using data analysis to identify them and to pick up any changes. So it's data, as you can see there on the side, they're data analysis, monitoring, and the detectable signs is making sure workers understand what the signs are and what to do when they detect those signs. Because by the time you get to that third phase, the pain and dysfunction, then it's very, very hard to backtrack, and then you've got a claim, and then we know what the cycle is. Once a worker has a claim, there's all those other issues that come in and make it a difficult return. So the biological onset and detectable signs section is where there's the most opportunity to reduce injury risk. So I'll talk a bit more about that in the next few slides. Load calculation. This is an interesting one. This is a topic that I've had many debates about over the years. In sports, as the slide said earlier, in sports, when you're calculating load, it depends on the variables needed for that sport. So you've got GPS, you've got blood lactates for aerobic athletes, you've got sympathetic nervous system for certain sports, you've got recovery through heart rate variability. There are 20, 30 odd variables that you can use for sport, but they're not relevant for the workplace. And so early on, I was measuring GPS and I was measuring heart rates and we were measuring stress response. And that's where workers were starting to push back and say, well, no, I don't want my heart rate measured because my new manager might say I'm not working hard enough and work me harder. Or I don't want to be tracked around the warehouse because that's the big brother monitoring sort of system that we want to avoid. However, there were some variables. So here's a table with all the different variables that can be used to calculate load. And I say can be, they are used to calculate load in sports. And they're all valid and they're all reliable and they're all really good tools. But at times you can get a little bit overwhelmed as to which of the variables are the most relevant. And so I started using all of these in the workplace, and in the end, we got back to the basics. So there are different types of load. There's internal load, physiological load, RPE wellness questionnaires, heart rate, galvanic skin response, and temperature. Now, out of all of those, RPE and wellness questionnaires, and RPE is rate of perceived exertion. So that's just simply asking a worker to rate at the end of the day how the load or how the physical demands were for the day out of 10. And of course, that's very subjective, but also it can be very skewed. The workers are going to answer it often depending on what they want their manager to think rather than what they actually felt. They don't want to say it was too hard because, or they probably don't want to say it's not hard enough because then they'll be worried the manager will work them harder. They might want to say it's too hard because then they might lose their job. So heart rate, galvanic skin resistance, which is a measure of stress response or sympathetic nervous system activity, and temperature. Those three are a bit too invasive. Workers aren't a fan of that sort of thing. And like I said, they don't want heart rate measured. VO2 blood lactate is definitely not practical in the workplace, but it is a really good way of monitoring fatigue. Never going to happen in the workplace though, unless there's some really cool new technology that enables it to be done with done remotely somehow. Who knows? But it's external load that we care about. Now, this is actually measuring the worker's movements. Time duration we've been measuring for a long time. It's the accelerometry that is the most interesting thing. And as I said before, it's the accelerometry measures the quality of the movement, the efficiency of the worker's movement. So you could have two workers doing the same thing, doing the same task. One could be moving more efficiently, more controlled. The other could be moving a little bit more frantically, a little bit more erratically. They're the ones who are going to fatigue quicker. They're the ones who are a higher injury risk than the ones moving smooth and efficient. And that's not just my opinion. That is decades of sports-based research that shows efficient movements result in less energy expenditure, less fatigue. And we know when you're fatigued, that's a very high musculoskeletal injury risk. GPS, as I said, it's a good tool on sports fields, but most workers aren't a fan. In the US, I spent some time in the US earlier in the year, and they have a lot of sites where the workers are forced to wear GPS, but in Australia, it's not so much the case. Forced dynamometry and power was an interesting one. That's why I've highlighted it there, because forced dynamometry, I found early on we were measuring resistive forces, push-pull forces, because a lot of employers were saying, well, it's the stress and the strain of pushing and pulling that we're concerned about. And so, yeah, we measured the force, and the force to do a particular task is the same for all workers. However, the way they generate that force is different. So you could get the same trolley to be pushed by the same 10 workers, and every one of them will move slightly different to push that trolley. So the force is the same. So yeah, we can measure the force, but we're more interested in how the people generate that force, and that's done through using the accelerometer. So it's time duration and accelerometry that are the key variables that can really easily be used in the workplace to identify injury risk. And again, if you have any questions with these, feel free to type them in and Stephanie will read them out. So monitoring load. So I've talked about load. How do we calculate it? So what if we've got a number that shows what the load is of the worker? What do we do with it? Well, you monitor it to identify change. So as I said before, simply measuring range of motion is not enough. And you've got to measure you've got to be aware of the different types of load. External load, biomechanical load is what we're talking about. Physiological load, we can't really gauge in the workplace, but this is a really interesting stuff. Chronic load versus acute load. So acute load is a task. So you can measure the acute load for particular tasks that a worker will do throughout the shift. And then you measure the chronic load, which is basically their movements throughout a full shift. And there's research that show the acute load chronic load ratio, which we've collected enough data over the last 2 years to really be able to refine that ratio. The acute chronic ratio has a direct correlation with injury risk in sports. We're trying to demonstrate that in the workplace. So if you've got the acute load for tasks, if you've got specific tasks that have really high acute load, you know that there's going to need to be recovery time, which will then get the chronic load down throughout the day. However, if you've got a lot of high acute load tasks throughout the day, back to back to back, the chronic load is going to be huge. And it's that ratio between acute load and chronic load that's the key. And that's what we're really going to be working on. And anyone on this webinar, if you're keen to help us refine that, we're more than welcome to have partners on board to help us get the right answer, get that acute chronic ratio right so that you can accurately identify injury risk for individual workers. Now it's not just about reducing load as well. A lot of the time early on it was, well, yeah, if you reduce the amount of physical load for the workers, then they're going to get less injuries. But the reality is, and I've got a story, there was a dairy factory, cheese and butter factory that we did some work for several years ago, where they introduced a pallet packing machine. It was a robot, two of these big robots with the big arms that would take the items off the production line and pack them on a pallet and then wrap it up, and it was all done. That job used to be done by 4 or 5 workers, physically picking up the items and packing them on the pallet, ready to be shipped out to all the stores. Now those workers, they were physically strong. They were yes, it was physically demanding work. It was lifting, it was carrying. And if it was managed, it was actually good for them. It was good for their health and it was good for their well-being. However, when it wasn't managed, that's when they would get overload and injury. But what had happened when these robotic pallet packing machines were introduced all of a sudden these workers were taken away from the physical work and they were in the back room pushing a button on and how to work this robot. And all of them, when I went in there, they just said, yeah, look, these robots are great, but look at me. I'm weighing 30 kilos more. I'm unhealthy. I'm not as active as I used to be. And so that's when I suggested to this organization, why don't you intentionally switch off the machines for a couple of hours throughout the week and give the guys and girls the physical exposure. Get them out there and get them doing the physical work. Because unfortunately, when the machines break down, they have to go out there and lift again. And their physical capacity is not resilient to that. And that's when there's a massive injury risk. So the purpose of this slide is to say it's not about just reducing load, it's about monitoring load. Now this chart shows the training load and competition loads and injuries for a particular well-known track and field athlete. Who the red line is the one you want to look at because the red line shows the overall training load. And the biggest risk areas the research showed was not just the peaks where they were doing a lot of physical training, but it was also the troughs when they were in recovery mode and their training had dropped. The injury risk was high at the peaks and the troughs. It's the same with workers. We know, yes, if you're going to a busy time of the year and the workload is twice as much as it normally is, that's an injury risk because it's an increase in physical load. But we also know that if a worker has been off for 4 to 6 weeks on long leave, when they come back, their physical resilience for those work tasks has dropped. So that's a trough in their load, and that's where they are a high injury risk. Same thing with returning to work. We know if a worker's been off on an injury, we ease them back in because they've been in a trough for a while, and their physical resilience, their fitness, not just for the injured area, not just the strength around the injured shoulder or the back, but their physical conditioning of being on their feet or lifting their box or whatever their tasks are, has decreased. So you need to build that back up. So it's not about just reducing the load, it's about avoiding the peaks and the troughs. Sorry, I'm going the wrong way. So I'll give you a few examples quickly. This is how you can use data in a practical sense. So this particular task was a time distribution for a housekeeping task, and they all had a set routine of which items to do in which order. And there was no reason to it. It was just a matter of that's the way we've always done it, so that's how that we're going to keep doing it. And there was a lot of low back injuries for this particular organization because when you looked at the tasks, so each of this chart shows the 12 tasks. And when you measured the physical demand, so the blue is the back load and the arm is the orange load. So you can see the first 5 or 6 tasks all have high back load back to back. So your the worker's back stabilizer muscles are going to be fatigued. Then they go into a couple of arm high load, and then they go into the back again. So we suggested, why don't we get tasks 7 and 8 down here, maybe 7 replaced with 3 and 8 maybe where it is, or to break up that load on the back by doing maybe 2 or 3 high load back tasks, then a high load arm task with low back load. And they did it, and surprisingly, the workers were happier, and over time, the injury risk came down. So it was just a simple matter of looking at the task routine and the time distribution throughout that. Task repetition. So here's another food manufacturing company, and they had just random task rotations. Again, it was more just because that was the way they'd already done it, and random rostering. However, this is what a normal shift looked like. So the first hour of this shift, and this looks like a normal day shift. The first hour was huge, and then they had this recovery phase, which was good. Then they had another huge amount of load in the first third, but then the rest of the shift was relatively moderate. So we suggested, well, what tasks with these rotations, they're all doing the same task. What tasks are causing all of this load in the first half of the shift, especially the first hour? If you've got a worker that's just been in the car for an hour and a half and they get out and they're straight into the biggest load on their back first thing in the morning, it's not best for them. So they looked at taking some of the tasks out of that first hour and distributing them more in the middle of the day. So it evens up that load throughout the day. And that's, like I was saying, that acute chronic ratio. Here, all the high acute load was in the front end, and the chronic load shows that there was plenty of recovery in the back end. So distributing these tasks throughout the shift was an easy fix to that solution, to that problem. Oops, I'm going the wrong way again. Manual handling aid. This is a great one. So anyone who knows me has heard this a billion times because it's a great example of not just measuring task injury risk, but measuring load over a long period. So it's an airport bag room. We know there's manual handling. Safe Work provided them with a breach notice and a fines and all that sort of thing. And they said, you've got to put in manual handling aids. So they trialed 4 different manual handling aids. One's pictured there, the vacuum lifter, and there was a couple of other ones. And we found that for one bag, so this particular chart shows the load of moving one bag. So the blue is the load without the vacuum lifter, and the orange is the load with the vacuum lifter. And you can see quite clearly that the blue is higher. So the physical load moving the bag without the vacuum lifter was higher than the orange chart, which is using the vacuum lifter. However, using the vacuum lifter took twice as long. So that was an interesting thing as far as fatigue and recovery, because then when you look at the next slide, it shows the cumulative load over 5 hours. And we found that even though the vacuum lifter removed the vertical weight of the bag, it actually increased the amount of movement elsewhere. And the total load over a 5-hour period was much higher. So what we're looking at here, the blue lines were 3 different workers using the vacuum lifter, and the orange, yellow, brown lines and grey lines are a worker not using a vacuum lifter, just doing the normal grab a bag and throw it on the trolley. And you can see that over a 5-hour period, the blue load was significantly higher throughout. And that was just not so much, yes, it took away the vertical weight of the bag, but the reality is these guys were so efficient, the vertical weight didn't matter so much. They just grab it and throw it. It was that movement of positioning a bag from one place to another using the manual handling aid actually increased the load because it introduced all these extra physical demands. And yes, over time, you could argue that the more practice they get with the vacuum lifter, the more efficient they would get. And yes, that load would come down over time. So there is that training effect. But this particular sample, because the vacuum lifters were really expensive, this particular sample, they decided to not install them. So fatigue monitoring. And having said that, I know there's a vacuum lifter in a particular airport in Sydney that never gets used. So it's been installed, but the workers prefer to just grab the bags and throw them the way they always have. And in other sites as well, there's been a few. I've come across a few vacuum lifters that have been installed that aren't being used in different facilities around the country. But that's not to say they're not good. They're very good if the workforce engage with them and actually use them. Sorry, I'm off on a tangent now. Fatigue monitoring. So here's another example, building a supermarket display. So you can see there, it's these guys that build the displays in the supermarkets. They build the same display in and out. That probably, this particular worker was doing 3 in a day. So same task throughout the day, 2 different workers. However, the fatigue later in the day showed, so what we've got here is the chart on the left shows the lifting a particular box, a particular size box, same weight, early in the shift. So the fact that there's not a lot of spikes in that chart shows that the movement, so these charts shows the back load or the back orientation, the back angle, sorry, not load, the back angle. So the back angle, you can see they get above 90 degrees once or twice, but it's pretty much solid and stable, which means they're using their legs a lot. Whereas in the afternoon, you can see there's a lot more erratic movement and there's a lot more range, which basically means they're bending further, which means they're not using their legs as much. And that's primarily due to fatigue. They weren't rushed. There wasn't a deadline they had to make. It was they'd been doing it all day and their movement patterns had changed as a result of that fatigue. So this is exactly where late in the shift, the workers' movements start to look like this. This is where if they've got sensors on and those sensors provide them with alerts, those alerts are just enough to trigger their knowledge because they know how they should be moving, trigger that reminder of, all right, that's right, I'm fatigued now. I need to pay more attention to my back position. I need to pay more attention to moving with control. So what does effective injury prevention look like? Yes, manual handling training is current forms of manual handling training is relatively ineffective. However, manual handling training delivered effectively using nudge theory of behavior change. So if you haven't heard of nudge theory, it's taking the traditional approach of a training course of 2, 3, 4 hours once or twice a year or once every 3 or 4 years, as some companies do manual handling training. Taking all of that information and using nudge theory by providing it in small chunks intermittently throughout a year. So if you're coming up to a busy time of the year where there's a particular task that involves a lot of wrist activity, coming up to that period, they would get the training modules that are specific for that. So it's fresh in their mind as they come into that time of the year. They know what to look out for. If there's tightness in the muscles, they know what to look out for as far as having breaks, all that sort of thing. So manual handling training is effective if it's delivered the right way using nudge theory. Safe operating procedures, of course, that's a standard. Every task needs a safe operating procedure. Hazard identification and incident reporting. This is the key because of so many employers I've come to across the last couple of years have said, yes, we've got all the hazard identification, incident reporting. The worker goes to this manager, then this manager then goes gets the forms, and then the forms come back to the worker, and then the worker has to fill out the forms, and then the forms go to the manager, who then has to enter it all into the platform, and then the platform converts it into the dashboard, and that's when we get to see it. Well, if I was a worker, I wouldn't do it. And most managers will would hate it because everyone's busy. So the last thing they want to do is start going through all this paperwork and going through all this. So that needs to be easy. That needs to be a matter of a smartphone app, click a button, take a photo, use audio, speak into it and say, this is what happened at this time on this day, and this is the cause and this is what we've done about it. Click, and then it gets automatically uploaded into a dashboard for everyone to see. Incident reporting and hazard identification has to be easier. And mental health first aid is crucial. Fatigue management, we know that's a tricky one because how do you measure fatigue? So we'll get to that. Overall health and well-being is also very, very important and often neglected. So I've got the first three are specific to the task. The next three are specific to the environment. And then the bottom three are specific to the individual. So if anyone disagrees with that, I'd love to hear. But that's generally the categories that we've found seem to be the way it's broken down. Manual handling training, as I said, right versus wrong lifting techniques. Everyone moves in their own efficient way. So if you take someone and try to teach them a different way, especially if they've been doing a task for a long time, then it's going to break down. If you've got a worker who's got bad knees and you're saying you must lift with your legs, they have a really strong back, they've got developed really strong back and pelvis muscles, and you say, no, you're lifting the wrong way, you need to keep your back straight and you need to squat down deeper, they're going to blow out their knees. And obviously we know if someone's got a back injury, yes, they need to use their legs as much as possible. But it's not one size fits all. And there's research we know that supports that now. So individualized feedback to reduce load for those people. So the person with the bad knees, they get specific load monitoring for them. The worker with the bad back gets specific load monitoring for them. So it's individualized. Safe operating procedures. Yeah, there's a lot of safe operating procedures that are in place just because, again, it's observation and opinion, which 9 times out of 10 is great, but 1 time out of 10 it's not great, and as a result, a worker gets injured. So site and task data specific and participative ergonomics is the key. We all know participative ergonomics is crucial as far as if workers are involved in the process, then first of all, they're going to be engaged and they're going to pay attention. And if you come out with a process from them, they're going to do it. But also they're the experts. So the number of times a consultant has come into a work site and done a safe operating procedure for a task that they've never done themselves, obviously, is ridiculous. Without consulting the workers is madness. So consulting the workers and using site and task specific data. Even then, the number of times I've seen safe operating procedures for a particular task that's done over several different sites, and the different sites have a different arrangement, then they can't do the task the same, but they've still got the one procedure for all of the sites. So it's got to be site and task specific, and the workers have to be involved, which hopefully most of you know all about now, because there's enough research to show that you're crazy if you don't. Hazard identification, complacency and culture. Like I said, a lot of the times it's just too hard to report. So regular reminders and easy to use on the spot. So that's where wearable technology and smartphone technology make all of this so much easier. Manual handling training delivered through their smartphone, safe operating procedures turned into training that's delivered to their smartphone and compared to data, and hazard identification, making it easy. So here's an interesting one. It's a video. I won't click on the video because of the buffering and that's. But it's basically a particular environment that wasn't suited to what the worker was doing. This is a particular a container lashing tool. so shipping container lashing tool, and that's where we were making sure that what we're doing here is reflective of what happens on the actual ships. So the environment, hazard identification, we've already been through that. Incident reporting, it needs to be, well, at the moment it's time consuming, and a lot of sites have this no incident badge of honor, and a worker doesn't want to break that. So they won't report an incident so they can continue their 300 days without an incident on record. So making it easy to report and aiming to protect co-workers. Excuse me. And mental health first aid is a key, but again, I've seen so many times organisations have trained people through mental health first aid. They've got all this knowledge, they've got all these skills that's sitting in the office, and it's hard to filter that down to worker, especially in the blue collar industries. So there needs to be a way to identify the needs and deliver assistance privately and effectively, again, using wearable sensors and smartphone technology. Having an app where the workers can actually are prompted every now and then. How are you feeling? Are you happy? Are you sad? Are you fatigued? All of these sorts of signs are crucial, and these days smartphone technology can be used to identify those signs. And then the last one, the individual. So mental health first aid we've done because that overlaps with environment, fatigue management. If everybody on this call now was to do a particular task, moving 5 chairs from one side of the room to the other, everyone would do it in different ways and everyone would fatigue differently because of our levels of fitness, because of our genetics, because of our size, our weight, our age. There's so many variables. So rather than trying to find a magic formula for everyone, we should just measure everyone's movements. So if we put sensors on everyone and everybody did that task of moving 5 chairs from one side of the room to the other, we would see exactly who's moving efficiently, who isn't moving efficiently, and the ones who aren't moving efficiently can then get help to move efficiently so that fatigue doesn't become a problem and they end up hurting themselves. So data and feedback to the individuals is crucial for fatigue management. And overall health and well-being, culture in blue collar industries is really hard. I've done a lot of work in transport and logistics and warehousing, and there is the pie and soft drink culture there, which it's hard to break. It's always going to be hard to break. However, identifying individual needs to drive behavior change using nudge theory. If they've got this app on their phone that provides them with insights into what the carrot and the stick approaches, making sure they understand the consequence of eating poorly or the consequence of not looking after their health and well-being. But one thing I've really found with workers with blue collar workers in particular, is making sure they understand that their physical well-being is their way of earning a living. And if they lose that, they lose their way of earning a living. And yeah, they might go on workers' comp, they might go on welfare, but their quality of life decreases and the amount of money they earn is decreased, which then impacts their life outside of work. So you make sure that if you remind them of that in a subtle way on an ongoing basis, then more often than not, they will start looking after their health and they will start paying attention to niggles that may turn into severe injuries that will impact their hobbies or impact their quality of life. And again, it's about not just putting up posters around the worksite, because we know all those visual reminders just become background noise after a while. It's about engaging through the most common source of information these days, as much as I hate to admit it, but we all get most of our news and information through the smartphone. So if we can use a smartphone to make workers more aware of their health and well-being and more aware of their injury risk, then it's got to be a good thing. So again, wearable sensors and smartphone technology make all of this a lot easier. Fatigue management. So one of those slides that back there was focused on fatigue management, and this is what we're talking about. So this could be, this is a shift. It's actually looks like a night shift, so 4 p.m. through to 2 a.m. And you can see here the backload goes up and down throughout a shift, but you could argue that this is not a bad distribution of load throughout the shift. The backload is spread pretty evenly. Yeah, towards the end, there's a bit of a spike. Whereas down below, you can see orange is the arm load. There's this section in the middle where you've got a big extra piece of arm load, extra tasks that increase the arm load. And what that does as the shift progresses, you can see here, this chart on the right, the dotted lines are the occupation average. So while you look at this and think, well, yeah, it's evenly distributed, the reality is it's almost, this is where the worker crosses the occupation average, halfway through their shift. So the total load for their shift up here is almost twice as much as a normal shift. Now, if you weren't aware of that, then you'd think this is a good chart. Yeah, the load's distributed evenly, so they're fine. But the reality is this is a huge fatigue injury risk. Now, arm is the same. You can see where the solid line crosses the dotted line halfway through the shift. That is where they normally finish the shift. So if you look at the chart down the bottom, again, the two lines are the same, but they cross the occupation average line closer towards the end of the shift. But it's still that last hour of the shift, that's where fatigue is going to increase the injury risk. So with these particular charts, you want these solid lines to end below the dotted line. And again, this is how they monitor athletes. They monitor progressive load. They might make sure that where is it from the average? Yes, this is a heavy week, so we want it above the average, but then we want it below the average next week so that they can recover. So driving behavior change, this is hard. Individualized feedback, workers will respond to it to reduce the load. Site and tasks, data, and sorry, this is just a summary of all the ticks from before. So site and task data and participative ergonomics, regular reminders throughout the year and easy to use, easy to report incidents and hazards, identifying the needs and delivering assistance to individuals privately, collecting data and providing feedback, and which is the same as the top. You can see there's a bit of a repetition here because it's so crucial, and identifying the individual needs to drive behavior change. And smartphone apps and wearable technology are the key. And we're now at a point where we've been doing it for a couple of years and we've got results over a long time to show that load and injury risk does decrease with this method. This is how it works. Sensors send data to the smartphone, and the smartphone sends data to the cloud-based platform for anyone to analyze and identify to address the risk. And that's you guys, the safety professionals, get to see the data, and that's where the big decisions are made, because there's no point in collecting data if it's not monitored and managed. Now, this is the exciting stuff. This is what we're doing now with AI. So at the moment, yes, training modules exist. The worker receives the training modules. Hopefully it changes their behavior and there's a positive or negative outcome depending on when the training is delivered and how it's training delivered. And as I said before, if it's done once a year for an hour, 6 months later, it's not going to have an impact. So using nudge theory to break it down into small modules, you can measure the outcome. But then you introduce wearable technology to measure load as well. So you've got the training modules to change their education and awareness. You've then got the load monitoring to tie in by measuring their movements to actually show them what they're doing, which then hopefully would change the outcome and change the action, and you'll have a positive or negative outcome. If it's either way, if it's positive or negative, it's measured and can be addressed. But this is the exciting stuff. When you start linking the training modules to the load data. So the workers only receive the modules that are relevant to them. If they've got high backload, like that chart before, if they've got a shift where their backload is twice as much as the occupation average, they're going to get the back fatigue training modules so that the next day it's fresh in their mind and they know, all right, I'm a high injury risk because all my back stabilizing muscles are fatigued from yesterday. And this is the exciting stuff, because this is where workers only get what they need and it's targeted to them. It's not a blanket approach where everyone gets the same training. They all get the core stuff, the hazard identification and the slips, trips, falls and all that sort of stuff. But the specific stuff, the movement control, if you've got a particular worker who's not moving with control, the next day they'll get the training modules educating them on how to move smooth and the reason why it's important to move smooth. And then it feeds back. So it's this continual loop of they collect data, receive the training modules, see what the action is, outcome positive, negative, and then it goes back into the loop. So it's constant feedback and monitoring of the change and monitoring the effectiveness of the modules. And then you throw in a few question and answer components. You can assess their knowledge. So yes, you can throw training at them. How much is it going to stick? You can provide feedback to them with the load monitoring. How much are they actually going to change? You throw a few questions at them, and not too many. Every one of our modules only has 2 questions. One is the cause of injury, and the second one is how to reduce it. Keeping it simple. And it takes them 3 minutes, 4 minutes to do each module. They do one of those every week or every 2 weeks, and it's not overwhelming, and they actually do it. So that's the continual loop using AI to deliver the safety training. So it makes your lives easier as safety professionals, but we know that it's this data-driven model that drives the behavior change with the workers. And again, here are these green rectangles. It's all about wearable sensors and smartphone technology that enable this whole process to exist. And that's it. Hopefully you're all still awake. I haven't put anyone to sleep. There are no questions throughout there. So thank you very, very much for your time. And if you do have any questions ongoing, definitely look us up and get in touch.
All right, thank you, Scott. So there's time for audience members to submit questions via their control panel into the questions pane for Scott to answer. Question, Scott. You talked a lot about apps and smartphone technology to, for example, make incident reporting easy. Can you talk a little bit more about what apps are out there?
I'm not sure. I mean, that's something we built into our app. I'm not sure about what other apps are out there, and that's the reason why we built it into our app. So, and I say our app, we tailored a smartphone app to first of all collect data from wearable tech, so measure workers' movements and provide them with feedback. But then we've built in a lot of other components, one being the safety training modules, so they get delivered to the app. But now we're actually just trialing the engagement of hazard identification, where it's as simple as taking a photo and, like I said, talking into the phone and then clicking save, and that gets uploaded into the dashboard. There are a couple of other companies that are working on voice-specific risk or hazard reporting and hazard identification, but I think they're still in the early phase. Risk Talk is one, and they're still very early in the development phase. And I know Safety Culture are building a hazard identification feature into their iAuditor app, but I don't know whether it's been released yet. I actually don't know whether I should be saying that, but it will be available soon. I can't remember where I read it, but that's yeah. So it is getting a lot easier. But those are the 3 real areas where I've come across that hazard identification feature. But at the end of the day, it's not so much about the app. Yes, you can build an app and collect data, but it's how that data is presented to the people who need it.
Thanks, Scott. And there's still time to submit your questions via your questions window on your control panel to today's presenter, Scott Coleman from Preventure. Today's webinar has also been recorded and will be made available on the WorkSafe Tasmania YouTube channel. Scott, if the audience want to contact you, what's the best way to do that?
Well, there's a lot of information on our website, which is preventure.live, and in the app as well, which is also preventure.live. Otherwise, they can email me directly at scott.coleman@preventure.live or hello@preventure.live, either way.
Thanks, Scott. So just to remind everyone as well, WorkSafe Tasmania month concludes this Friday, the 30th of October. We are running webinars up until then, so please do head to the worksafetasmonth.com.au website to see what other presentations, online presentations, we are running until the end of October.
It's a great initiative, Stephanie. Are you going to do it every year?
Yes, WorkSafe Month is part of National Safe Work Australia Month,
Yep.
and it is an initiative that is run each year by most jurisdictions in Australia,
Yep.
and
I mean, the webinars, having the weekly webinars has been a brilliant addition.
yes, it has absolutely, Scott. So that predominantly came about because of the COVID restrictions that came into place. But it certainly is an initiative that will continue to consider to run next year and during next year's WorkSafe month as well.
Yeah, no, it's great. A lot of the other states do different things, but this is a really engaging and really good way of getting new information out and engaging people in the Safe Work Month. It's really good.
Thank you, Scott. So we'll wait a few more seconds to see if any further questions do come through for today's presenter, Scott Coleman from Preventure. And just to remind everyone as well that today's webinar has been recorded and will be available on the WorkSafe Tasmania YouTube channel in the coming days. So just before we do close, Scott, just to let you know a couple of comments that have come through. Brilliant, thank you, and thank you as well.
Great. Thanks, everyone.
So to close today's webinar, thank you, Scott Coleman, Chief Executive Officer and Injury Prevention Specialist from Preventure. And thank you everyone for attending today's webinar, Using Wearable Technology to Reduce Injury Risk. Once you do leave today's webinar, you will receive a survey on the presentation. We do appreciate you providing us with your feedback. Today's webinar has also been recorded and will be made available on the WorkSafe Tasmania YouTube channel. On behalf of WorkSafe Tasmania and the WorkCover Tasmania Board, thank you for joining us, and thank you, Scott.